Here we have a problem on identifying a function from a graph. So here we have a graph and we have to identify the function which represents the given graph over here. And we have four options. So now in the given four options, in the first options we have cotangent function, and in the last options we have tangent functions. Okay, so first let's consider the graph of the basic tan function, that is y is equal to tan x. So like if I consider the graph of the basic tan function, it will look like this. I mean the one pattern of the graph of the basic tan function will look like this. So if I look at the one pattern of the graph of the basic tan function from left side to right side, so on the left side it will keep going down, on the right side it must going up. So this is a one pattern of the graph of the basic tan function. And also if I consider the one pattern of the basic pattern of the graph of the basic cotangent function, that is y is equal to cotangent x, its graph must look like this. It is on the left side it must keep going up, on the right side it must going down. In case if there is a negative sign in front of this tan, then it will be switched. That means on the left side it will keep going up, on the right side it will keep going up. So this is a reflection of the graph of the basic tan function, this one. But I don't think there is no reflection, because when I look at each option over here, there is no negative sign in front of the given cotangent or tangent function. So we don't have to worry about the reflection of the graph. So if the given graph is a graph of a tangent function, so each pattern must look like this. If the given graph is a graph of a cotangent function, then each pattern must look like this. Okay, when I look at the pattern, each pattern over here, so clearly when I look at each pattern from left side to right side, so look at it, on the left side it keeps going up, on the right side it keeps going up. So it must be the graph of the tangent function. So because if it is cotangent function, on the left side it must go up, but here on the left side it goes down. So the given graph must be the graph of the tangent function. So we can reject the first option and second option. Okay, in option 3 and option 4 we have tangent function. So now we have to decide. Okay, usually when I sketch the one pattern of the graph of the basic function, that is y is equal to tangent x, so usually we'll graph the one pattern between negative pi over 2 to positive pi over 2. So like the graph will look like this. And also between negative pi over 2 to positive pi over 2, the graph of this basic tan function will pass through the origin, that is both the x-intercept and y-intercept will be 0, 0. But here when I look at the one pattern of the given graph, so let's consider here it's negative pi and here we have 0, then the value of x here must be negative pi over 2, and here we have 0, it's pi. So this is the exact middle value between the origin and pi. So now the value of x must be pi over 2 here. Okay, so I have one pattern of the given graph is between negative pi over 2 to positive pi over 2. So there is no phase shift or horizontal shift, because we have one pattern is between negative pi over 2 to positive pi over 2. Usually like the tan function, the graph of one pattern of tan function, basic tan function, that is y is equal to tangent x from between negative pi over 2 to positive pi over 2. In case there is a phase shift or horizontal shift, so the graph will be maybe moved to the right or left. In that case, I will not have this one pattern between negative pi over 2 to positive pi over 2, but here this one pattern of the given graph is between negative pi over 2 to positive pi over 2. There is no phase shift or horizontal shift. But when I go to option D, so 2 is added to x. That means there is a horizontal shift of 2 units to the left, because 2 is added to x. So there is an horizontal shift, phase shift of 2 units to the left, but the graph is not shifted to the left or right. So right now we can reject option, the last option also. So probably the third option must be correct. Anyways, we have to make sure. So for that, what we need to do is, so as I said, so when I consider the graph of the basic tan function, that is y equals to tan x, so the one pattern must be between negative pi over 2 to positive pi over 2, and also it must pass through the origin 0, 0. But when you look at the pattern of the given graph, one pattern of the given graph between negative pi to positive pi over 2, it does not pass through the origin 0, 0. Instead of passing through 0, 0, it passes through the point 0, 2. So what do we think about this? So the graph is shifted 2 units up. So that means that there is a vertical translation of 2 units up. So here 2 is added to the tangent function. So this positive 2 represents a vertical translation of 2 units up. So clearly this one represents a vertical translation. So again, the third option proves the vertical translation of 2 units up. And also we have to consider this number 3 over here. So whenever in the basic tangent function, there is a number greater than 1 multiplied in front of tangent, it's a vertical stretch. So here 3 is multiplied in front of tangent, so there is a vertical stretch by a factor of 3. That means at each point on the graph of the basic tan function, the y-coordinate has to be multiplied by 3. Okay, so for example, let us consider the basic tangent function, that is y is equal to tangent x. Okay, in this y is equal to tangent x. So here, for example, if I plug in x is equal to pi over 4, what will happen? So it's a 45 degree. So from trigonometric ratio table or unit circle, we can get the value of this tan pi over 4. It's just 1. So when I plug in x is equal to pi over 4, so I'm getting y is equal to 1. So the point I'm getting over here is pi over 4, 1. Actually, this is a point I have on the basic tangent function. So here you have a question, why should I take a particularly pi over 4 for x? So because I know that for tan 30 degree, I'm getting square root of, 1 over radical 3. Radical 3 over 3, or for tan 60 degree, I'm getting radical 3, but for 45 degree, I'm getting an integer of y. That's why I consider the angle measure pi over 4 for x in this basic tangent function. So we have the point pi over 4, 1 on the graph of the basic tangent function. Pi over 4, 1 means pi over 4 is 45 degree. So it is the exact middle value of 0 and 90 degree. So it has to be here, the pi over 4. And here we have 2, and it must be 3, and also it must be 1. So pi over 4, 1 must be here. But we don't have this point on the graph. Instead of that, we have a point over here. So the x value corresponding to this point is here is the same pi over 4, but the y coordinate is 1. So not y coordinate is 1, y coordinate is 3. So clearly the y coordinate 1 is multiplied by 3 here. So the pattern over here reflects the vertical stretch by a factor of 3. The reason is, so here when I consider the point on the graph and the point of the basic tangent function, the y coordinate 1 is multiplied by 3. So this represents a vertical stretch by a factor of 3. So, all the evidence we have in this option, there is a vertical translation of 2 units up that we find in the given graph, and there is a vertical stretch by a factor of 3 that we find in the given graph. So the correct answer choice for this question is the second option, that is y is equal to 3 times tangent x positive 2.